Hemianopia means half not see, or blindness of half the visual field. In this example, both the left eye and the right eye only see the right side of the world. We call this left-sided homonymous hemianopia. To understand why someone can be blind in half of the visual field, we use this top view of the visual system. Here the eyes are located and they are looking at the outside world, which we divide in a left half field and a right half field. The right half field is imaged onto the left side of the retinas. The left half field is imaged onto the right side of the retinas. The signals of the right half field, here shown in yellow, will end up for both eyes in the left part of the brain. Oppositely, the signals of the left half field will end up in the right part of the brain. We will now find out what happens with the image in each eye if there is a blockage somewhere in the visual system. If there is a problem with the retina or the optic nerve close to an eye, then this may result in complete or partial visual loss in that eye. Since it is unlikely that half the visual field is affected, this kind of visual field loss is not called hemianopia. If there is a blockage in the chiasm, here, the spot where part of the signals overpass to the other side of the brain, then hemianopia can occur. In this case, the side of the blind half field differs between the eyes. So, one eye sees only the right half side and the other eye only sees the left half side. We call this bitemporal hemianopia. If the blockage occurs after the chiasm, the hemianopia will express itself the same way in both eyes. We call this homonymous hemianopia. With the blockage in the right side of the brain, the left half field will disappear. After all, the left half field ends up in the right part of the brain. Blockages even further down the visual system may cause so-called quadrantanopia. This we will not discuss further here. After this more theoretical introduction, we will try to show you what hemianopia means in practice. To do this, we make use of an eye tracker. This is an apparatus which can determine the gaze direction of a subject. Homonymous hemianopia is simulated by removing the image on a monitor on the left or the right side of where the subject is looking. Here the simulation program is started. Next, a color is chosen for the blind half field. In reality, this of course does not have a color. It simply is not there. As can be seen, the blind half field is being adjusted to where the subject is looking. The appearing semicircle simulates a possible macula sparing. This means that the central sharp vision is unaffected. The simulation of the hemianopia can be both right-sided and left-sided. We will now look at some visual tasks. First, reading. It is maybe difficult to see, but here the subject reads each line rapidly in 4 or 5 eye movements. With right hemianopia, it shows that reading is slower. The reason is that the subject now cannot see the words in advance. The speed of reading goes down even further if there is less or no macular sparing. With left hemianopia, it is easier to read to the right, since now the words can be seen in advance. The problem with left hemianopia is more finding back the beginning of the next line. This is again more difficult with less macular sparing. A simple aid is to use a ruler or other straight object. It also helps to have a contrasting stripe at the beginning of the lines, so it is clear where the text begins. We will now look at moving images. The Hemianopia simulator is started. It already becomes clear that we are missing things. The game is easier to follow when the ball moves away from the blind field. Watching a soccer game with Hemianopia is very tiring. We only had to miss half of the visual field for just 1 minute. But already it feels good to get the whole visual field back. Maybe you are wondering why a person with Hemianopia does not look at the edge of the monitor as indicated here. This seems to give a better overview. However, it should not be forgotten that the person is now also fixating there. If you keep looking at the same spot, you will notice that the center of the monitor is now less clear, especially if multiple objects are present at the same time. We hope that this movie helped in your understanding of Hemianopia. Hemianopia can be disabling and also tiring. Adaptation, together with knowledge and training of eye movement strategies, will make sure that the condition will become less disabling.